16? What page was it? Okay. All right. So being asked about number 16 on page 27. And this is of the first packet. So we have x over 2 plus 5 over 6 equals x over 3. That's the one you're interested in? Yes, okay. All right, so the instructions here aren't very clear, but you're supposed to solve for x. We know that because it's an equation. It's a linear equation in one variable, meaning we have the equation, we have one variable, it's raised to the first power. So if you recall the steps for this, let's see what page those steps were on, just so you can refer back to them. They're on page 19. So there are 3 steps. Simplify, which meant distribute or clear parentheses, clear fractions and decimals, combine like terms. So we have fractions here. We want to get rid of the fractions. So what we're going to do is find a least common denominator. Just a second here. That didn't work. It's better. Okay. We want to find a least common denominator. So that means you look at all the denominators, 2, 6, and 3, and you try and find the least common multiple of all of those. So if you just list out the multiples of 2, 4, 6, 8, 10, then list out all the multiples of 6, so 6, 12, 18, keep going. And then the multiples of 3, 6, 9, and keep going. I'm looking for the smallest number that they all have, every list has. So 6, 6, 6. Ooh, welcome back. 6, 6, 6. So that's going to be our LCD. All right, so what do we do with that LCD? Once we find it, what do we do with it? Multiply both sides of the equation, both sides, by that 6. Now on the left side, I must use parentheses because there are 2 terms, and I'm going to multiply everything by 6, so each term has to get multiplied by 6. On the right side, there's only one fraction, so I'm just going to multiply it by 6. Remember that 6 is the same as 6 over 1. So when you multiply through this first one right here, you're really doing like 6 times x over 1 times 2, because multiplication of fractions is straight across. When you do the second one here to here, you're doing plus, because there was a plus sign between them. You're doing 6 times 5 over 1 times 6. I'll get to the right side in a second. On the left, we have 2 options. We can just multiply 6x over 2. 6x over 2 is 3x. Or you could, before you do that, realize that 2 goes into 6 3 times, 2 goes into 2 once. And then that's just 3x over 1, which is just 3x. But I'm writing out a little more detail because you asked about it. On the next one, I could just cancel the 6's and be left with 5 over 1, which is just 5. On the right side, remember that 6 is 6 over 1. Multiplying straight across, I would have got over here, what, 6x over 3? Again, you could have reduced the 6 over 3, or you need to reduce 6 over 3 and make it 2x. So, is that okay so far? Once you've done all that, then you collect like terms, which there aren't any. So then you move, the step says then isolate the variable term. So I'm going to subtract 2x on both sides, which will make it go away on the right, leave me with a 0. Left side, 3x, take away 2x is just x. And we're almost there. We want that variable by itself, right? So do what to both sides? Subtract 5. Goes away on the left. We just have the x. On the right, 0 take away 5 is negative 5. And we're done at that point because the number in front of x is 1 already. So that's our answer. Does that clarify? Okay. Any others? 6, same set. So page 24. Okay. Number 6, page 24. 5 parentheses x plus 2, close parentheses, minus 2/3 x plus x over 2 equals 6x minus 11. This is a good problem to have a question on, because there's a little bit of an issue we have to deal with, and if you're not careful, you can deal with it incorrectly. We're looking first to simplify, so you want to get rid of parentheses, you want to clear fractions. Which one do you want to do first? You want to do the parentheses first? That's fine. Now, you could clear fractions also first, but that's where you might run into a little bit of an issue. Let me distribute through. The 5 can go through the parentheses, can't it? So that'll be a 5x plus 10. And then I'm just going to rewrite everything else. At this point, I want to clear fractions. So I look for an LCD. What do we have here? What's the LCD? This one's kind of easy to get. 3 and 2, common multiple of both is 6. So I'm going to multiply everything by 6, both sides of the equation. Everything. Everything. Yep. Because remember, on an equation, what you do to one side, you have to do to the other. So whatever's on the left has to get hit with this LCD, and whatever's on the right. You can't just pick which pieces you want. It's got to be the whole thing. Yep. Yep. Everything. Yep. I mean, the equation, remember, is like a scale, right? I mean, it's balanced. An equation is balanced. So if you do something to the left, you have to do it to the right. It must be for everything there. It can't just be for one part of it. So I'm going to come in here with my 6, the 6, and then I'm just going to write the entire left-hand side in parentheses. And then I'm multiplying by 6, and then the entire right side in parentheses. So you only need parentheses if you have more than one thing. Like on the previous problem, when I multiplied the 6 on the left, I had to use parentheses because I had 2 terms. On the right, notice I didn't use parentheses because I only had 1 term over here. So multiple terms require parentheses. And that way, on your next step, when you distribute the 6 through, the 6 will go to everything here, and then the 6 will go to everything over there. So what is 6 times 5x? 30x. 6 times positive 10, 60. All right, what's 6 times negative 2/3? So 6 times negative 2/3 is the same as 6 over 1 times negative 2/3. Multiply straight across, negative 12 over 3 is negative 4. Okay, and always keep in mind that you don't have to do it that way. You can reduce out, however you want to do it. All right, multiplication of fractions you can clear. No, sorry, that should be a 2. Thank you, thank you. 2 right there. Sorry. 3 goes into 6 twice, 3 goes into 3 once. So our result here is -4. So when you multiply over here, I'm talking about this multiplication right there. When you do that, the number in front will be -4, and then you still have the variable there, x. How about 6 times x over 2? Just 3x. 6x over 2, which will be 3x. And we're done on the left side. Right side, 36x minus 66. And now you can proceed with collecting like terms. So let me see, I have x here, I have take away 4x, I have add 3x. I can put all those together. How many x's will you have if you put those together there? 29 x's, 29 of them. So I have 29x, still have a plus 60, equals the right side, which there was nothing I could do over there, right? So you can subtract 36x on both sides, or you could subtract 29x, whichever way you want to go with it. I'm going to go with what was said because it's the first thing that was said. So we'll go way over here on the right. What about the left side, though? What's 29x's take away 36x? Minus 7x, or negative 7x. Still have plus 60? We will subtract 60. So I'm going to do that on the next line. Subtract 60, and brought my calculator today. I don't need it for this one, but I hope I don't. All right. Negative 7x equals, what is that? Negative, well, I thought negative was positive. I'm trying to confuse you on purpose. Just want to make sure you know. Negative? Okay, don't get upset. I'm just making sure. Just want to make sure. All right, so since you're subtracting, not multiplying, it's going to stay negative. And what do you say it was? 126. And then to get the x by itself, we must get rid of the negative 7 that's being multiplied, so we divide by negative 7 on both sides. X equals 18. Goes in there clean. All right, that good? Yes. Mm-hmm. You mean like the type of answer? No. Something like this, just get a solution. Yeah. Just remember that if you were to get something like, 2 equals 5, you would just say no solution, right? Okay. This would, yeah, one solution. That's okay, we have to move on. We have a lot to do. We're a little behind. So let me bring it up. So far, what's your feeling on this packet approach? Because like I said, I haven't used the packet before. I mean, feel like you're getting anywhere here? Yeah? It's not as distracting with a bunch of stuff in there that you... Yeah. Okay. I've been curious. I didn't check it out yet, but wonder if anyone... Let's see here, playlist. Remember, all these videos are online. Let's see. See if I'm going to get my feelings hurt here. Okay, so I've had 2 views of that video and 3 views of that one. And then the first day, let's see how many I had. 6 views. All right, so that's better than nothing, right? Maybe, yeah, we'll see. I know it's hard to sit and watch a video, especially if it's 2 hours long on math. I mean, but, you know, it's there. All right. Yeah. Same set here of problems. The answer is 0 then. That's different than empty set. The answer is x equals 0. The only time you get an answer of the empty set is if you got something at the end where your x's all went away and all you had was something that didn't make sense, like 2 equals 0. Then you would say there's no answer. That's right, and that would still leave you with 0. 0 divided by anything other than 0 is 0. All right, so we are supposed to pick up with percent, ratio, and proportion. And then after this, we get into like metric, scientific notation, things like that. Some of this stuff I think is actually kind of applicable to real life. You know, we deal with percentages a lot. We deal with ratios and proportions. I know that there are some people who might be interested in medical fields when you're converting like milliliters over to something and making sure that's correct. You know, how do we do that? So there's a lot of that in here. A ratio is a comparison of two quantities written as a fraction. So if you say the ratio of 5 feet to 7 feet, you can write it a couple of different ways. 5:7, 5 divided by 7, or 5 to 7. 5 divided by 7 is usually the one we use in a math class. So anytime we have a ratio, we can convert a ratio into a percentage. So recall that whenever we say 1% of something, we're saying that if you take this something, let's say it's a candy bar or something, cut it into 100 pieces, one piece out of the 100 would be 1%. 50 pieces out of the 100 would be 50%. 70 pieces of the 100 would be 70%. So the ratio here, 1 over 100, or 1 to 100, is representative of 1%. And how do we go from 1% over to a decimal? Y'all remember how to do that? If someone writes 1%, we can imagine that there's a decimal point right there, right after the 1. And then to convert it to a decimal, we move that decimal 2 places to the left. To the right. So it creates zeros when it moves. Sorry, I went the wrong way. We want 1% to a decimal. Other way. Move it 2 places to the left. So 0.01 as a decimal. So to change a percent to a decimal, move the percent's decimal how many places, what direction? 2 places to the, I just confused you, right? To the left. If you're trying to go from a percent to a decimal. I'll give you another example underneath this. If you say 50%, what is that as a decimal? So here's your decimal point. Move it 2 places to the left, and now it becomes 0.5. You don't need the 0, but you can put it. It's not wrong. 0.5. Okay, so if we want to go from percent to decimal, move 2 places to the left, and drop this percent symbol. Make sure you drop the percent symbol. If you want to go the other way, a decimal to a percentage, you're going to reverse it. You're going to move this back 2 places to the right, and you need to add the symbol. If you want to go from a fraction to a percentage, you have to actually do the division. So we're going to get some practice in here. All right, let's take this. Let's take 5%. Let's write it as a decimal. What is 5% as a decimal? 0.05. We moved it 2 places to the left, right? Our decimal point was here, 2 places, 1, 2, creates a 0. That's where we drop the decimal. So 0.05, get rid of the percentage symbol. How about 3,500%? 35.0. We can put 2 zeros if we want because the decimal went 2 spots to the left. So 35 is 3,500%. How about 3.35% as a decimal? So we move the decimal 2 places to the left. So it becomes 0.0335, drop the percentage. What's 0.2%? 0.002. So we move it 1, 2 places, creates a 0. So we're going to have 2 zeros in front of the decimal. So on the next ones, we can use calculator unless we know what they are. We're going to try and go from a fraction to a percentage. So first thing, let's figure out what 1 divided by 4 is as a decimal. What's 1 quarter? 0.25? Everyone agree? You can do it on your calculator if you don't know that. Then convert that to a percentage. To go from decimal to percent, we move it to the, which way? To the right 2 places. So now we move the decimal to the right 2 places, and we write a percentage after it. So this will become 25%. Let me zoom this in a little bit. Is that large enough for you to read? Okay. First to a decimal, decimal up to a percentage. How about 1/5 as a decimal first? Was it 0.2? And now bring it up to a percentage, move it 2 places to the right. So what? 20? Right, 2 places to the right meant 1, 2. How about 1/3? What's that as a decimal? 0.333333333 forever, right? So I can't write that forever, so I may as well stop it somewhere. And we like to put a little bar on top of the 3, which represents that that goes forever, doesn't it? The 3 repeats itself. Now move your decimal 2 places to the right. And you get what? I can't fit it in there. 33.3 with a bar on top of it %. You know what? I don't think I remember what it's called. Yeah, because later on, like in the different, you know, as you get higher in math, you don't write a repeated decimal. You actually leave it as 1/3 because you don't want to get rounding problems. So you just leave it as a fraction. But repeater bar sounds great. What about the next one? What is it? 16 point, no. So what is repeating on it? The 6? So it's 0.1666666. Okay. 0.1666. Seems to be the theme of the day. 3 6s. And move the decimal point 2 places to the right. Can't fit that in there, so what do we have? 16.6. You can just put the bar there. %. Just don't forget the % symbol. How about 1/9? 0.11111 forever. So this one is 0.111 forever. Now I could have put the bar right there on the first one, but I gave myself 2 1s before I put the bar because I know I'm about to move the decimal 2 places to the right. So I may as well give myself something to work with. Go. And so what do we have here as an answer? 11.1 repeated percent. All right, these will go a little faster. This is 0.5, 50%. 2/5, 0.4, so 40%. 2/3, 0.666. So this is 66.6 repeated percent. 5/6, 0.8333. So 83.3 repeated percent. And 2/9, 0.222 repeated, which is 22.2 repeated percent. Any questions on that? That's pretty straightforward, right? So, you know I like to go off on little tangents a lot, so I'm going to go off on a little tangent. I have a question for you. If you were to look at, you know, we're familiar with the number line, right? You have the numbers on the number line. Here's 0, here's 1. They go forever in each direction. The number that's halfway between 0 and 1 is a half, right? And my question to you is there a number, or what is the number that is directly to the left of 1? 0.999 forever? Like 0.999 repeated? That's a great conjecture that could probably be it. Anyone have anything different? 0.99999 forever? What's that? So 0.9 would be somewhere around here, because 0.91 would be bigger than that, right? That's right. So how about this? Y'all think this seem reasonable to you? Okay. So let me write something down, and then you're going to tell me whether or not you agree with me or don't agree with me, all right? You just yes or no. Let's see if we can make sense out of this. I'm going to call X 0.999 forever, which is what we think is the number right next to 1 to the left, right? Now, if X is this, then what would 10X be? Tell me what 10X would be. So I'm saying multiply this side by 10, multiply this side by 10. That's right, because multiplying by 10 has the effect of doing what? Moving the decimal to the right 1 time. So this would be, what, 9.999 forever? Do y'all agree with that? Okay, so if I say that X is 0.999 forever, and we all agree then that 10 times X should be 9.99999 forever. Now, purely, forget all the numbers here, just think of this algebraically. What if I ask you right now, what's 10X take away X? How many X's will you have? 9 X's? All right. Now, rewrite what was 10X. What did we say 10X just was? 9.99 forever. Take away from that X. What did we say X was? 0.999 forever. What would happen if you take 10X and you subtract from it X, 0.999 forever? What happens to this? The 0.999s forever cancel each other out, and what would you be left with? 9? Do y'all agree? So you mean to tell me 2 things. 10X take away X is 9X, right? And you mean to tell me that if I were to have written these as, you know, this is x, this was 10x, that if I actually do the computation, it equals 9. So you're telling me that 9x equals 9, right? This computation, with the numbers replaced, should equal 9. Without the numbers replaced, it should be 9x. These two have to be equal. Okay, solve this equation. Get x by itself. X is equal to 1. What is this saying? This is saying that 0.9999 forever is not the number right next to 1. It actually is 1. All right. I said I was going to go off on a tangent. There is no number right next to x. Next to 1. As soon as you try and find it, you realize that you missed 1. Actually, you missed an infinite number of them. It is impossible to be the number closest to x. If you remember, if you've taken a math class before this, have you ever seen where we're trying to say on the number line, like everything between 2 and 3, we want everything between that, but we don't want to include the 2 points? Have y'all ever seen something like that? And so we use this thing, this open interval, we go 2 to 3, and we use parentheses, not brackets. Y'all seen that? The reason why we do that is because I can't tell you what the closest number to 3 is. I can go all the way up to 3 without getting there. But I can't, there is no number right closest to 3, so I cannot tell you where to stop. All I can tell you is go to 3 but never get there, if that makes sense. Get as close as you want without getting there. You could look at it that way. Another way to look at it is if I'm trying to get to the wall, let's say the wall is 3, I can go halfway there and then halfway there and halfway there and halfway and never get there, and there's no number right next to 3. So there's no gaps anywhere. There's no empty spaces. All right, we're way off. Sorry. That's why I like this class, because we're not here to, like I said, build bridges and put planes in the air. So we can go off on tangents. It's okay. Everyone's going to be fine, right? All right. So to construct, this was all just, you know, working with decimals and fractions and percentages. Now we want to look at some translation from word problems into equations with percentages and fractions. We know how to work with them. Now let's see how we use them. To construct a percentage from language, 3 out of 5 students means 3 divided by 5, right? 3 out of 5, 3 of 5, which as a decimal, we divide it on our calculator, get 0.6, and as a percentage is 60%. One of my friends has a shirt, and it says, I think it says 5 out of 4 students hate math. You can't do 5 out of 4, right? I mean, it doesn't make sense. 4 out of 5 makes sense. 5 out of 4. So, I mean, he has a shirt that says that 5 out of 4 students hate math. It might say 3 out of 2. I don't remember, but the idea. All right, so let's see if we can try and translate this first example. A study of Northwest Vista College pre-nursing students showed that 11 out of 235 already were licensed as LVNs. What is the ratio of nursing students who are LVNs in percent? 11 out of 235. So what is that as a percentage? So what are we going to set up here? 11 divided by 235. So we first set up the ratio, right? From that, we break out our calculators. We do 11 divided by 235. And we get this nasty decimal. It's equal to 0.0468. It depends on your calculator how far this goes out. Mine goes way out. 0.85106. As a percentage, what is this? We move the decimal point 2 places to the right. Yes. And so we get 4.8 6, 8, and then it keeps going, but I'm going to stop there. 2 decimal places after 2 to the right, and I'm going to say percent. So about almost 5%, right? Almost 5%. Understand? Okay. Now, whenever we're doing these problems, word problems, there are some words that come up within the problems that always mean something, and we all need to be aware of these words, because when we see them, we automatically will replace them with symbols. So first, percent, the words. Percent, if you see per, each cent equals each 100. I have no idea what the hell they mean by this. Per, okay? Per is going to make you think that you're going to be setting up a ratio. Or out of, you know, when they were to say 11 per 235 students would still mean 11 out of 235. Say math words. Whenever you see of usually means, anyone know what of? Let's get to is. Let's get to is. We'll come back to of. We're going to do of with an example to help us see it. Is equals, that's the easy one. Okay? Is means equal sign. This is this, so you have equality between the two. What means what? It's the thing you want to find, right? Like, what is the ratio of nurses at NBC? What is the quantity you're trying to find, right? This is usually represented by the variable which we'll call x. Yes, this is what you're looking for. We usually represent it with x. You could use any letter you want, really. X is the standard one. So of, go back to of. Letter. Yes. Not the multiplication symbol. Yes. Variable. Letter. Of is multiplication. Now, let's work through a problem, and you'll see how this works, okay? 21 is what percent of 200? So let's try and write this just left to right. 21 is equals what percent is x? Of right there is our multiplication, and then 200. Do you see it? Okay, solve for x. What do you need to do to solve for x? Remember, this 200 times x is the same as 200x, isn't it? The multiplication, I can flip it around, and now we have a linear equation. It's already, parentheses are gone, there's no fractions, collecting like terms, isolating the variable, all that's done. All you have to do is make the coefficient on x 1. So you divide both sides by 200. So what do you get? You get 21 divided by 200, 0.105. So 0.105 equals x. Now that's the answer as a decimal. But look at what we wanted. What percent? What percent? So 10.5. Now let's go back and let's just see if it makes sense. If our answer makes any sense at all. I'm going to just come up here and write 10.5%. See if this makes sense as an answer. 21 is 10.5% of 200. Does that make sense or not? What would 10% of 200 be? 20, right? So 21 should be a little bit more than 10%. Understand? So we always want to kind of put our answer back in to see if it kind of makes sense or not. If it doesn't, then there's something wrong. Let's try the next one. 15% of, so 15%, whenever we're working with equations, we want to get rid of percentages and we want to convert them to decimals. So write the 15% as a decimal. 0.15 of is what? Multiplication, so dot. What number is what we're going to solve for? I'm going to call that x. Is equals, right? 19.5. I'm just going to rewrite it all over here. 0.15 times x equals 19.5. So I don't need the dot between the 0.15 and the x because it's multiplication. I just put them side by side. And what do I do next? Divide both sides by 0.15. So take 19.5 on your calculator, divide by 0.15, 130. 130 is what it looks like the answer is. So let's just check it to see if it makes sense. 15% of 130 is 19.5. Yes, you could check it here. Yes, but that would just check that you solved it correctly. It would not check that you set it up correctly initially. To do that, you need to go back to the word problem and see if it makes sense. So let's see if we can reason this. I'm not quite sure what's going to make most sense to you in your mind. What would 50% of 130 be? What would 50% of it be? It'd be half of it, right? 65? Okay, so 50% of it would be 65. How about half of that? So 25% would be half of 65, wouldn't it? 30-something? Look at our number. Our number's even smaller, isn't it? So it makes kind of sense that it would be 15%. What's 10% of 130? 13? We're wanting more than that, 15. So look, our number is bigger than 13. I don't know. You just kind of have to, whatever you're comfortable with. That's right. There you go. See, but I'm not quite sure if everyone's on the same page with you when you do that. You know what I'm saying? Like, of course, you and I did the same thing, but I can't assume everyone's going to do that. You just want to make sure, like, if this said, like, if your answer here was 2, then you're like 15% of 2 is 19. Whoa, wait. That wouldn't make any sense, right? 15% of 2 should be smaller than 2. And then, yeah, all right. What about this one? You write this one down yourself. I'm going to pass this around. Sign-in sheet's coming around. What's the equation? There you go. 25 is equals 40% is 0.40. I just put 0.4. Of is times what number is x? and then we just solve that. So you're going to divide both sides by 0.4. What do you get? 62.5 equals x. So 25 is 40% of 62.5. What about this one? You set that one up. .35, what? Of is times 200, is equals, and that's what we want to know, right? What is that equal to? So just call it x. So there's no, you don't have to isolate x, you just need to do the multiplication. What is that? Careful, your decimal needs to, your percentage must go to a decimal. What is it? 70. Then what would your answer have been? It would have been 7,000? Yeah. Yeah. Yeah, because if you would have got 7,000, then 35%, which is less than 100%, right? 35% of 200 is 7,000. That wouldn't make a lot of sense. Let's move on to number 7. I think you've got those others. We won't do every single one of these problems. All right. 30% of all students at MVC transfer to UTSA. 12% are going into biology. What percent are going to be at UTSA in biology? That is a confusing problem. No, because they said what percent are going. They want to know. Mm-hmm. Well, hold on. We got to make sure we are all interpreting the problem correctly first. We'll get into whether or not it's enough information, all right? So let me draw a picture. Here are all the students at MBC, right? How many of them are going to transfer to UTSA? 30%, right? There. There's 30% of the students. Those students are going to UTSA. All right. 12% of that 30% are going to biology. Okay, that's what this means. It should say 12% of those students transferring are going into biology. That way we're clear on it, because you could mean, okay, 12% of the students at MBC are going to biology. No, 12% of the 30%. Okay, so let's let X be equal to the number of students at NVC. Total. All right? That's all the students, everyone. I should have done it in green. All right? That's everyone. How many of those are going to UTSA? 30%. So wouldn't that be 30% of X, which I could write as 0.3X, right, are going to UTSA. right? That's how many students are going to UTSA. 0.3 times X, 30% of the total number of students. Then, of that, 12% of those students are going into biology. So 12% of what, though? The 0.3x are going to biology. So how do I rewrite 12% as a decimal? 0.12 of is multiplication, 0.3x. And this is going to UTSA with biology. Does that make sense? You have the 30% of everyone first, then of that 30%, 12%. So if you wanted to, you could break this 30% right here, whatever that group is, and you're taking a smaller percentage of that group, 12% of that group. So to do that, you do at the end of the day, you do 12% times 30%, or 0.12 times 0.3. So what's 0.12 times 0.13? Or 0.3? What? 0.036x. I'm running out of room. This right here becomes 0.036x. What does that mean as a percentage? 3.6%. Well, you got to be expecting something like that. I mean, all of these are fair game. Any questions? See, now look at this one. 30% of all students at NBC transfer to UTSA, and of these students, 12 are going to biology. If they're, how many will transfer to biology? So look, this is I believe they mean this to be the same question. They're actually giving you how many students. Now, how many students did we say it would be? 0.036x. And what was x? Number of students at NBC. So this is the same problem. We just now are going to replace the x up here with 15,435. Does that make sense? So I need to do the 0.036 times x, but I know x now is 15,435, which is are you kidding me? We're going to take 0.66 of a person. Let's say approximately 555. The little squiggly equals, a little equal sign that's squiggly means approximately. No, because you can't have 0.66 people. Well, you could argue that a person is less than a whole person, but you know, that's a philosophical argument. All right. Number 9. If there are 425 statistics students at NBC, of which 35% plan to attend nursing school, what proportion of the 15,435 NBC student body does this represent? So I think this is where we run into the biggest problems in math, right? Is with these word problems and trying to interpret them. So I personally like pictures. If you don't like pictures, I'm sorry. Let's see. We have you want that to be everyone? That's all of NBC. How many are in there? 15,435, right? Within that 15,435, there are 425 statistics students at NBC. So in that group, there are a group of stat students. It's 425. Got it? Now, of the 425 statistics students, 35% plan to attend nursing schools. So what is that group? What's that? They're inside the blue circle, right? Because that is within here is 35% of them. How many is that? 35% of the 425. So that group right here, yellow, that group right there is 35% of the 425 stat students, right? That is 0.35 times 425. Go ahead and get that on a calculator. $148.75. Yep. Pretty good. Pretty good. So why don't we say that that's approximately what? 149? So of the 425 students within the stats group, right? 35% of them are going to go to nursing. Well, that means about 149 of them are going to go to nursing. Understand? All right. What proportion, what fraction of the 15,000 students at NBC does this represent? There you go. 149. So what we want to know is this group in yellow, what proportion is that to the entire student body of NBC? So 149 over 15,435. Well, that's what I was going to ask you next. What proportion? If it's a proportion, we can leave it like that. That's 149 over that. Or you could write 149 colon 15,435. Or you could say, in words, 149 of 15,435. Any of those answers would be correct. Up here? Well, no, I mean, you don't need to use it, no. Yeah, so if they asked you what percentage, right? Yeah, it would come out to be less than 1%. So that means that of that group, right? No, not of the group. If you take the entire NBC body and you look at the students who are going to nursing school that are stats majors or stat students, then they comprise less than 1% of the total student body. You have a headache yet? In a Gallup poll, 976 students of 976 adults, 68 said they have a drink every day. A, meaning a single drink, right? The other 900 and something have multiple drinks per day. No. What is the percentage of respondents who said that they have a drink every day? What is the percentage? 68 divided by 976. That one's pretty straightforward, huh? We could say, though, here, what percent, right? That could be our X of is multiplication. The respondents, that's the equation. But just divide. You already said what it was, right? 68 divided by that. And what was it? 6.96%? I won't be real critical on that. Yeah, I mean, you just don't want to round that to 10%. You know, 7% is fine. You can leave it at 6.96%. All right, proportion. A proportion is a statement that one ratio is equivalent to another ratio. As an example, 2 over 4 is the same as 3 over 6. That is what a proportion is. Example, walking at the rate of 7 miles in 2 hours, how far can you go in 3 hours? What's that? 10.5. So how are you doing that? Okay. Okay, so that will probably work. We're going to approach it a little bit different, though. All right, so here's, because what you did is you found out how many miles you go in 1 hour, and then you multiplied that times 3. I'm going to do the same thing, but I'm going to do it a little more systematic. I'm going to actually set up a proportion. So the first piece of information says you go 7 miles in 2 hours, right? I'm going to write as a proportion 7 miles per 2 hours. Right? 7 miles per 2 hours. That is a ratio. I go 7 miles in 2 hours. That must be equal to or proportional to however many miles I go in. How long am I interested in? 3 hours? And this is what I want to know, right? Which I'll call X. But we want to know what miles I put in here, right? X miles in 3 hours. How far will you go in 3 hours? So the ratio or the proportion must be equal. 7 miles in 2 hours is proportional to some number of miles in 3 hours. So let's look at all the units first, all right? Everything here cancels. You can almost imagine divide both sides by miles and it goes away on both sides, right? Divide miles on both sides. You can also multiply both sides by hours. So hours go away on both sides. Which means the equation really becomes 7 over 2 equals x over 3. So how do you find x? Get x by itself. You have to get rid of the 3 down there. 7 times 3. So you're going to multiply both sides by, you want to do 3 or 6? It doesn't matter. You can get it both ways. Do y'all care? All you want is this guy by itself, right? So you want the 3 to not be below it. So you can multiply this side by 3. What you do to that side, you must do this side. The 3's on the right side will cancel because 3 over 3 is 1, which leaves you with just an x. On the right side, what is this? What does the 3 multiply times? The 7 or the 2 or both? Just the 7 because that's like a 3 over 1. So you get 20, what's 7 times 3? 21 over 2. And then 21 over 2 is 10.5. And it's miles, isn't it? One plain bagel has 320 calories. How many calories are in 2.5 bagels? So again, I know you could try and figure out different things, but let's try and set up a proportion. How do you want me to set up the first proportion? One bagel, I'll just say 1B, over what? 320 C for calories, is that okay? Is equal to, now we need to do bagels and calories again. 2.5 bagels over X calories. Understand? How many calories is what you're trying to solve for? So you have to put the X on the bottom. Now we don't like 2.5, right? You want to use 2.5? Okay, so this whole thing becomes 1 over 300 equals 2.5 over X. Now we have not run into this yet. The X we're trying to solve for right now is in the bottom, isn't it? In the denominator? We have not run into this. How many of you have ever seen when you have a proportion, two fractions equal to each other, you can do this thing called cross multiplying? Have you all seen that before? Okay, that's what I'm going to do, but just be very careful about the whole cross multiplying thing because I don't want you to do it incorrectly. What you're really doing, let me show you how you do it first and then I'll show you what you're doing. You multiply this times this and this times this. So what is X times 1? X, that becomes the new left side. What is 320 times 2.5? 800? And you have X. You're done. That's it. That's called cross multiplication. You can only do it when you have a fraction equal to a fraction. It's the only time it's valid. When the X, you can do that to any fraction, but whenever X is on the bottom, that's when it becomes useful, because by doing that, the X appears on the top. But here's what you're actually doing. You're multiplying both sides by X. Am I allowed to do that? And what happens to the X's on the right side? These cancel, right? This X is going to multiply times the 1. I'm also multiplying both sides by 320. What's going to happen to 320 on the left side? They cancel. And really, it's going to be the 2.5 times the 320. That's all you're doing. You're multiplying both sides by X. You're multiplying both sides by 320. But it has the effect of looking like this cross-multiply thing. So I just want you to know it's not just some crazy math thing that we make up. It has a solid mathematical foundation to it. So 800 what? What's our units? Calories? A leaking pipe can lose 24.7 gallons of water in a week. How many gallons are lost in 30 days? Tricky. Okay, so look, the first ratio, 24.7 gallons per what? A week is 7 days. Good. You have to see that in the problem because the other proportion, they're saying how many gallons would be lost in what? 30 days. Do you see that if you had left this as 1 week and then this is 30 days, the proportion would not be okay? Everything has to be in the same units. So 1 week, we convert to 7 days. See, now this is a case where you would not want to cross multiply because to get X by itself, all you have to do is get rid of the 30 below it, right? So you only want to multiply both sides by 30. You don't want to go multiplying the 7 to the X because then you're going to put a number in front of X. So cancel out all your units. 30 on the right goes away. 30 on the left goes to the top one. So I'm going to do 30 times 24.7 divide by 7. 105.857 something. I'm going to say 86. And again, this is where I would not be too hard on you if you got something really close to that. That's gallons. Joe's heart beats 11 times in 10 seconds. At that rate, how many times does his heart beat in 60 seconds? So I'll set up the ratio 11 beats per how many seconds? 10 seconds. That must be proportional to however many beats he has in 60 seconds. And since all the units are the same, I don't have to worry too much. What will I do to solve for the x? Multiply both sides by 60. So how many beats is that? 66. Is that a lot? Beats. Is it a lot? Is that a high heart rate? 66 beats per minute? Almost what? There's a low? Like an unhealthy low? Okay. Yeah. Before I got married, I used to do triathlons. Because before you get married, you can do a lot of things you want to do. So anyways, and I remember I fell off a 24-foot ladder and luckily survived the fall and broke my arm, but I had to get a plate put in it. And so I went to go have the surgery, and it was like right before the surgery, and they checked my heart rate, and it was like 52 or something. It was like super low. I was probably about, I don't remember. I don't know. It was probably, I was in my late 20s, early 30s. I was doing triathlons back then. Yeah, I know. That's what I'm saying, though. It was like really, really low, and they were freaking out. They were like, "Are you nervous or anything?" I'm like, "Yeah, I'm nervous. You're about to go put me to sleep. I may not wake up, you know." And they're like, "Your heart rate's like really low." I'm okay. So that's why I was asking you, is there like a low, like dangerous low? All right. Okay. All right. I think I'm tired of these problems. Are you? All right. Is it break time? All right. It's break time. 10 minutes. See you back at 3:25. All right. Okay, so now we're going to go into what we're calling the principles of percent. All right, some things that we deal with, real life taxes, or not taxes, sales tax, things like that. So remember that for tax, when it comes to tax, the price of an item plus the price times the tax rate is the total you pay, right? You go buy sandwich, you pay the base price of the sandwich plus tax. Now, if you put money into a bank, then they give you what's called interest. Or if you borrow money from a bank, you have to pay interest. That interest is always the principal, which is the amount that you put in or or the amount that you borrowed, we call it the principal, times the rate, which is your percentage, 5%, 1%. If you're borrowing money, 26%, things like that. Time is usually measured in years. So you multiply those three things together, that's the interest. That's the amount of money you'll have to owe back. Total money is your principal plus your interest. So if you put $1,000 into a bank, they give you a certain rate, you collect interest on it, you add that interest to how much you put in, and that's how much total money you'd have in the bank. So simple interest is principal times time times rate. It's what we call simple interest. There's more complicated ways to compute interest, but that's the most basic one. Whenever you have a percent increase or decrease, let's say, for example, I'm trying to think of a percent increase, something real world. Let's say, can you all think of something that's increasing? Okay, we can do a paycheck. Yeah, but let's do it the other way, where let's say you're making $15 an hour and they give you a raise, now you're making $17 an hour. What was the percent increase? So to do that, you do your new rate, which is 17. You subtract your old rate, which was 15. So there's a $2 increase. You divide that by your old, 15, and that's your percent increase. Now, you can also have percent decrease. Your performance sucks, and they say now you're making $13 an hour. So you do your new, which is 13, minus your old, which is 15. Now you're going to get a negative ratio, and that means it's a decrease. All right. Here we go. Amy bought a pool hall for $219,765. That's a pretty common real world situation, right? You just go out and buy a pool hall. That happens all the time. This price includes 5% state tax. What was the price of the pool hall before tax? 5%. Yeah, 5%, whatever that is. So what do we know about the price here? This is the total, isn't it? That's with tax. Your total is always equal to the price plus the price you pay times what? The tax. Right? That's the equation we have. Well, order of operations means you have to do the multiplication of the tax first. Okay? So, what is it that we know in the problem? What are the things that are given to us? We know the total, and we know the tax rate, which means we're going to be solving for the price. Yes? So let's just fill in the things that we know. 219,765 equals the price, can we call it P? Plus the price times tax. What was the tax? 5%, but we always want to use the decimal form, 0.05, so 0.05 P. So I put the tax in front of the price because it's a number. I don't know what the price is, so I put it behind it. 5% is 0.05, but I put a 0 in front of the point. Just a lot of times books will do that because sometimes if you just write this, people will miss the point. For some reason they'll forget that there's a decimal there. So they put a 0 in front to kind of make it clear. All right, what can we do to solve for P? Now we can add them together, right? We can add the P's together because this is like 1P plus 0.05 P's. Add the two coefficients together, and you get 219,765 equals how many P's? 1.05 P. And then divide both sides by 1.05. I'm getting P is $209,300. That's how much she paid for it, and then she paid tax on top of that. After tax, it was $219,765. The tax plus that number, right? Because if you just do that number times the 5%, you're going to get just what the tax was. Yeah. So how much tax did she pay? You could subtract the 2, right? Or you could just multiply that times 0.05, either way. All right, Chris needs to buy his sister a birthday gift from the mall. He sees a shirt that is $24.50, but it's on sale for 20% off. If the sales tax is 8.25%, how much will Chris pay for the shirt? So the shirt's normally $24.50, but today and only today it's 20% off. Okay, let's look at the I'll call it new price. The new price is how do we get the new price? Okay, so there's 2 ways of doing this. You can figure out what is 20% of that, right? That's how much you would have to take off the price, right? Or you could say, instead of looking at it as in 20% off, 80% of that price is what you're going to pay, right? That's the way I think is a little easier to do, especially if you're at the mall and or somewhere and you really want to do it. Instead of trying to figure out how much to take off, just figure out what percentage you're going to pay. So the new price is 80% of $24.50, which is 0.8 times $24.50. I don't like that dot there. I'm just going to put a parentheses around it. That means the same thing. So we get 0.8 times $24.50, which is $19.60. So now that shirt is discounted. It's going to be $19.60. How much is Chris going to pay for the shirt? Well, now he's got to pay tax on that, right? So the total is going to be equal to the price plus the price times tax. So the total is going to be not $24.50. It's $19.60 plus $19.60 times the tax. What's the tax? 8.25% converted to a decimal is 0.0825. And go ahead and what operation do you do first? Multiplication. The 19.60 times 0.0825. So you have 1960 plus, I'm getting 1.617. I'm going to put 1.62 because it's cents, so we're going to round up. Again, I wouldn't take off if you didn't round. Understand that? This piece right here is this. This is just this. Add them together. What do you got? Chris decides his sister's not that important and she's not worth $21.22, so he gets her something else. But this is a good exercise for him. I have a question. This is not off topic or tangent, it's on topic, but I want you to consider something. Let's say you have an item for sale, right? And you have 2 options, 20% off or you can take 10% off and then 10% off again. So a good example of this would be like, I know like Lowe's and Home Depot, I've run into this before. I have a coupon, I can get 20% off. But I have another coupon, I can get 10% off, and if I use my charge card, I get 10% off again. So is it the same thing? It's not. Sure? Okay, so let's say something cost $100. What would 20% off be? 20% off would be 80%, right, is what you're going to pay of 100, which is $80. Okay, that's how much it would be. So what if I do $100 and I take 10% off? What's that going to be? 90%, right? 90% of 100, which is $90. And then I take off 10% again. So from this, I go and do 90% of $90. What's 90% of $90? So 0.9 times 90. 81. $1 more. So if that was $1,000, you'd be paying, $10 more. So it's not the same to take 20% off the top is not the same as doing 10% and then 10% again. Kelly takes his friends out to lunch and pays for the bill. His friends insist on paying the tip. If the bill was $38.75 and they want to leave 15% tip, is that cheap? Is that a good nowadays? 15%? 15% of the total? Or what's proper these days? Tax times 2? So what's tax rate? Well, I know, but what's the tax rate? So it's about 0.8. So if you double that, you're 16%. But that's 16% of the subtotal. That's right. So you're doing 16%. If you tip double the tax, you're doing 16% of the subtotal before tax, which is different than doing 16% of the total. So I'm not saying that's wrong. I'm just saying you have to understand what you're actually doing there. You're not accounting for any one-weight tables. I weighted tables all through college, so I mean tips matter. Some people tip off of the subtotal. Some people tip off of the total. Some people tip off the service. Some people don't tip very well at all, no matter what. So, all right. So let's just say they want to leave 15% tip. All right, off of that number. So how do you compute that? You just want 15% of that number, right? 15% of 38.75. So multiply 0.15, right? Times 38.75. What do you get? That's a terrible tip. But okay, so let me reverse this, okay? Let me go back on this. And do this real quick. I'm going to challenge your philosophy of doubling the tax. Okay? So check this out. If I take, let's say the total bill was $38.75. Let's say the tax rate was 8 point, isn't it? Is it 8.15? 25, okay. Let's say that's the tax. What was the subtotal of this bill? What was how much did they pay for this food before taxes? So how did we determine that earlier? We did total was the price, right? Plus the price times the tax. Are y'all with me? The total is 38.75. The price we don't know. The tax rate is 0.0825 times P. Look, does everyone understand we've already answered the question? Okay, but I'm getting back to this, you know, do you tip off of subtotal, total, you know? Let's see what would be better here for the waiter, all right? So put the two P's together, you get 38.75 equals 1.0825 P. Divide both sides by 1.0825 and you get 35.79. So how much was the tax? So subtract these two and that's how much the tax was? Okay, so tax was, what did you say, two what? 295? And so if you double that, right, if you double that, 2.590, 2 times tax is 590. Okay, so tax times 2 appears to be relatively close to a 15% tip on the total bill. Appears that way, yes. Again, I think that this is open to interpretation because of the word they. How much money will the need to leave together? So I think it means they. When they say they, do they mean his friends? Or do they mean they as in everyone including Kelly? The whole table? But it says they. Doesn't necessarily. That's what I'm saying. It's open to interpretation, I think. I know. So when I write your test, it will not be open to interpretation. All right. It'll be very clear. All right. Because this is the type of thing that can make word problems very confusing, is when the wording is not clear enough for you to understand what's happening. I think you could say both ways. If you're talking about the group of people as friends, they need to leave 581. The whole table needs to take that number and add this number, and that's how much they need to leave altogether. Okay? I always tip 20% of the total because it's an easy computation, right? You can usually take this number, round it up, 39, do 39 times 2. Whatever that is, move the decimal, and you've got it. So what would it be? Roughly, if I say this is 39 bucks, what's 2 times that? 780? 780? To move the decimal 2 places, 780 is what I would tip on that. I probably would have rounded this to 40 and then done 2 and then just would have left $8. That's because, I mean, that's, yeah. I remember this table. I'll tell you a story. I had this table, this guy goes in, I was working at, well, hold on. All right, so let's see if we keep money. Okay, this one we need to go through. Simon puts $375 in an account that earns simple interest. So remember simple interest right here, principal times time times rate. So it earns simple interest at a rate of 6%. You can't find 6% nowadays. There's no way you're going to put money in a bank and get 6% back. You're lucky. You're lucky. 2% is even pretty high. If he keeps the money in the account for 5 years, how much interest will he have earned? Okay, how much interest will he have earned? So interest will be equal to the principal times the what? Rate times the time. We usually measure it in years. So if they give you like months, you have to convert it to years. So what was the principal? How much did he put in initially? 375. What's the rate as a decimal? 0.06. And then the time? 5 years. Just do it in the calculator. Yeah, simple interest. It's simple interest, not compounding. 112.5. That's how much interest he earns. Now, how much money will he have in all at the end of the 5 years? Total will be what he started with, 375 plus the 112.5, which was what? 50. This is all money, right? Dollar sign there. Dollar. Let's just look at this real quick. Let's turn this around. What if instead Simon borrowed $375 because he opened this credit card at his favorite little whatever shop that he likes, and the credit card is charging him not 6%, but what more like reality, 25, 26%? Let's go with 26%. If he keeps the money in the account for 5 years, so that means he's like making minimum payments on it. Actually, what we compute is like he made no payments, but minimum payments is basically like no payments. How much interest is he going to occur in 5 years? So that would be like 375 times 0.26 times 5. Let's just see how much interest that is. Ooh, 487.50. That's just the interest. Now he has to pay back what he originally borrowed too. So he has to pay back that plus 375. So at the end he winds up owing 862.50. So I mean that's how a bank works, right? That's all a bank is. You go to a bank. Here's a bank. Right, don't be jealous, again, my drawings. Okay, you come in here and you put your money into the bank, right? They give you an interest rate. They say, hey, we're going to pay you to let us borrow your money. And we're going to give you something ridiculous like 1.2% for your money. And then Sally comes along and is like, I'm a college student, I'm poor, but I really need this purse and this phone and this and that. So they open a credit card account, right? And they borrow it at 26%. So the bank goes and takes their 26%. They give you your 1.2%, and everything else is theirs. That's right. That's right. They're going to give you. I mean, back in the days before the bottom fell out, you know, you could put money in a bank and get 3 or 4% just for it sitting there. I mean, in a checking account. Now you have to lock it up in CDs or things like that. But what happened was this. What we realized at some point is that there were a majority of Americans who were doing this. And so it turned out they couldn't, all they were doing is making minimum payments back. So there was a big question of whether or not that debt was ever going to be paid. And if that debt's not going to be paid, this bank isn't going to make its money back. And then they're going to have to owe these people money back, or their bank will fail. So they reduce this percent because they're not sure how much of this they're getting back, right? And credit cards were being used for not just like, hey, I want to go get a purse and I really want this phone. It was like, I need food, I need gas, and my credit card at 26% is what I'm using to survive. You're using credit. And where's the bank getting money from? China, right? Other countries that are lending our banks money, and so they're basically lending Americans money. Anyway, okay, I'm not going to get into this, but well, of course, the CEOs of most companies are, yeah, yeah, yeah. The thing is, you know, when I was in college, when I first started college, I could have had 50 credit cards if I wanted to. I mean, they were raining down on me, credit cards. I mean, just everywhere I turned, here's a credit card, and I didn't open any credit cards. I stayed away from them. But you know, nowadays it's a little harder to get credit because I have excellent credit, and even like at Home Depot or something, like, you know, they're not willing to like bump your limit up too much unless they're really convinced you're going to pay it back. So it's a lot harder now to get yourself into this trouble. My best friend in college, I think he accumulated like 80 grand in debt, and he eventually went bankrupt and got himself out of all that. Now he's finally back. I mean, way later. But they made it too easy back then to get yourself into big trouble. But that's the way the bank works, though. I just wanted you to see. It's still interest. It's just money you lend them, they give you much less back than the people who borrow it. All right. I don't know. That's the problem, is that really, if you look at the way America is, the people need the bank more. They need the credit more. Yeah, that's right. That's right. You're not going to sit here and go, hey, look, if you're not going to give me money, then I'm going to go to a different bank. And the other banks will say, we're not going to give you money either. 26%. That's the rate. Deal with it. Or don't have gas and don't have food. It's sad. All right. What's that? Oh yeah. Oh yeah. Yeah. Well, nowadays you have to have something, right? Used to be, it's like, you know, check your pulse. All right, here's $10,000. Have fun. All right. Destiny needs to put aside enough money at 5% simple interest that will grow to $3,000 in 1 year. What amount will accomplish this goal? So Destiny is going to try and put money into a bank. They're going to give her 5% for the money. At the end of 1 year, she wants to have $3,000. How much does she need to put in initially? So let's go back to the formula for it. The total she'll have, right, in the bank will be the principal. That's how much she puts in, right? Plus the principal times the rate times the time. Right? This is interest. Right here. Principal, rate, time, that's interest. You add the interest to how much she put in, and that's how much she has total at the end. Y'all understand that? That's just the equation we're going to use. Now let's look at what are the things that we know in this problem. 3,000 is what, though? That's what she wants at the end, right? The total is going to be 3,000. What else do we know? The rate is 5%. The time is given to be what? She's given herself 1 year for this to happen. You know everything but the principal, which is the amount to go in. So just fill everything in here. 3,000. By the way, is that formula on this sheet? Let me see. Yeah, it is. Principal plus interest. But what's interest? Principal, rate, time. So if you replace that interest with this, you have that formula. It's a little hidden in there. Do you see it? This is principal plus this whole thing right here is interest. I'll call it I. Principal plus interest is your total. Make sense? I'll call it P for principal plus principal times rate, 0.05 times time. Time is 1. Put these two P's together. What do you get if you put these two P's together? 1.05, right? This is 0.05 P, and you add to it 1 P. So 1.05 P equals 3,000. So divide that through. Good luck, Destiny. She basically has to have about $3,000 to have $3,000 at the end of a year. I mean, it's so close because the interest rate's so small, 5%. Dr. Presley is selling his BMW 740 on consignment by leaving it with a dealer who will get 25% of the selling price. What must the selling price be in order for Dr. Presley's share to be $48,750? So I've never even heard of this before. I guess people do this. You take a car into a dealer, you say, hey, go sell this for me. You get to keep 25% of the sale price. Yeah, but I don't know how many dealerships will just buy your car outright. You know, this is like a secondhand clothing store basically for a car, right? You take your old clothes into the store and you say, hey, sell all my clothes, and you get to keep 25% of it, and I get to keep 75%. They do the selling, and but you don't get all the profit. Okay, so let's see what we're going to do here. Mm-hmm. It's like the shirt sale, yes, with a 20% off. What we have here is that the 48,750 is equal to 75% of the selling price. Can everyone interpret it that way? The dealer is going to get 25%, which means Dr. Presley is going to get 75%. The 48,750 represents the 75% he wants. So the selling price, let's just call it X. Convert the percentage to a decimal and just divide through here. 48,750 divided by 0.75, $65,000. I don't know why Dr. Presley's selling his BMW. Maybe because it's a BMW. You know? $65,000 is what that need to sell it for him to achieve his goal. All right, here's an increase-decrease problem. In 2004, Sam bought a new television for $2,500. In 2012, he purchased a similar model for $950. What is the percent decrease from 1999 to 2003? What? I have a bigger problem. The years don't match, do they? 1999. It was a good year. I mean, yeah, they meant really what's the difference from what, 2004 to 2012, right? So what's the difference? It's not even the same TV, so that's kind of weird, but all right. So what's the formula? New minus old over old. New minus old over old. So what's the new price? $950. What's the old price? Over old price, right? New minus old over old. Where is it? New minus old over old. And let me talk with the other faculty and ask them what they are doing. Well, which is why this is your last math class, right? Okay. So we're going to get a decimal here. It's going to be negative. I'm getting negative 0.62, which is a 62% decrease in price. Why is it decrease and not increase? Because it was negative. I do 0.62 converting over to a percentage, 62%. So basically we're paying 62% less now than we used to for the same TV because technology better, things are getting cheaper. The price of gas increased from $3.25 to $4.05 per gallon. What is the percent change to the nearest percent? So new minus old over old. New is 405. Old over old. New minus old over old. Do the subtraction up top first. That's what that big division bar means. You have to do all of that up top first before you divide. 0.8 over 325. 0.246, which is 24.6% increase. Spurs question. If the Spurs finish the season with the record 55 wins and 27 losses, what percent of their games will they have won? What? How many games did they play? They played 82? 82 games total. How many of them did they win? 55. So 55 out of 82 is the percent wins. We'll convert from a decimal to a percent. 0.67. I'm rounding here. I'm not including all these numbers, so 67% wins. We made it to the homework. So the homework is very similar to what we just did. There's lots of word problems in here. We've got some proportion problems. Remember on these proportions, like something like this, cross multiply, cross multiply, cross multiply, cross multiply, cross multiply, a bunch of those. Taxes and things, proportions, more ratios. Just look and see if there's anything in there. It's too crazy. Man, that's a lot of stuff. That's just too long. How are we doing? What time do we go out? 4:40? We're on metric. We were supposed to start metric conversions and scientific notation today, and then also do dimensional analysis today. So I'm a little behind. I don't know how we got so far behind so quickly. Maybe because I'm talking about a bunch of stuff I don't need to be talking about. All right, let's see what we can do here. We got about half an hour left. All right, metric conversions. The metric scale is used to represent quantities in a nice uniform manner using a base 10 system. So that if you have something like 10 centimeters, then 10 centimeters would equal 1. What's 10 centimeters? Equals 1. No? No. Okay, we're not there yet. All right. Let me try something else. 12 inches is 1 foot, right? What's 12 feet? Is that something we know real well? Like, I mean, there's not a nice conversion. Like, you go 12 inches, make 1 foot, then you would think, okay, 12 feet should make something else. But it doesn't. It's 3 feet makes 1 yard or something like that. So that's the US system, and it sucks because it's not easy to convert from one unit to the next. Like, how many inches are there in a mile? I mean, that's a difficult thing to convert, right? The metric system makes things a little easier to convert from one to the other because everything is just a matter of moving the decimal point left and right. That's what the power of metric is. So there's a phrase that we can use to help remember things. I don't know. Has anyone ever heard that phrase before? King Henry died, unfortunately, drinking chocolate milk. I don't know. KHDUDCM is what you need to remember from that. And what that gives us is the metric system scale. You have K stands for kilo, H is hecto, D is deca, and then U for unfortunately is your unit, your basic unit, which is the middle unit. And then keep going. D, this one is not deca, it's deci. And then the C here for chocolate is centi. And then the last one here, M for milk, is milli. So King Henry died, unfortunately, drinking chocolate milk. Now, that's the basic metric units. But when we say kilo, hecto, we now need to be talking about what it is we're measuring, all right? Grams would be a measurement of what? Like a weight. So if you say kilogram, that's a weight. If you say kiloliter, you're talking about a measurement of volume. Not weight, but volume, the amount of space that's taken up. If you say kilometer or kilometer, you're talking about a measurement of distance. So for each of these units, weight, volume, length, you have the King Henry died, unfortunately, drinking chocolate milk. So kilogram, hectogram, decagram, gram, decigram, centigram, milligram. Got it? Kiloliter, hectoliter, decaliter, liter, deciliter, centiliter, milliliter, and then meters, okay? Now, the thing that's good about this scale is that if someone gives you anything on this scale and you want to convert to something else, it's just a matter of moving the decimal over. That's all it is. So if you want to move down the steps on this scale, you're going to move the decimal point to the right by however many steps you want to go. If you want to move left on the scale, you're going to move the decimal point to the left. So let's take an example here. Let's try and convert 0.58 centimeters to meters. Now notice there's nothing in front of this meters. It's not kilometers, km, it's not dm, right? It's just m. So this isn't that our basic unit? Meter is our basic unit. It's the one in the middle. So I'm going to go up to this little chart. We are given what? cm? Right here? Sorry, cm. So I have, what was the number again? 0.58. So we are right here, 0.58 centimeters. And I want to convert that to what? Meters, which is the basic unit, which is up here. So I need to go up the steps to get there. I need to go how many steps? 1 to here, and then here, 2. So I'm going to move my decimal point 2 places to the left on this. So move it 2 to the left. 1, 2, and let's put that answer right underneath here. What is it? 0.0058 meters. Understand? All right, let's try the next one. 0.0058 meters. All right, 4.7 what? kg stands for kilograms into cg, centigrams. Not used very often, right? Centigrams, but we could do it. So I'm going to come up here, 4.7, I'm going to put it right here, 4.7 kilograms, and I want to go all the way down to centigrams. So I'm going to move 1, 2, 3, 4, 5 positions, right? 5 steps. So I'm going to take the decimal point that was right here, 4.7, I'm going to move it 5 to the right, which would be 47000. Is there 4 zeros? And then put behind that what? CG, centigrams. So 4.7 kilograms is 470,000 centigrams. Y'all with me? I think the next one's okay. And the next one, well, I'm just looking for something interesting. Here we go. Let's go to G. 2,000 milligrams to what? DG. So is that decigrams or decagrams? Yeah, so how do we tell the difference between deca and deci? Deci would just have a D in front of the unit, so DG would be decigrams. If it was decagrams, it would be DAG. So let's do that one. It was this one right here. So I'm going to go put 2,000 in the milligrams position. 2,000, use a color I haven't used. 2,000 milligrams. And I want to take it where? To this one, decigrams. So I want to go 2 positions, 1, 2. So when I move up the steps, I move the decimal to the left 2 places. So what does it become? 20 dg, decigrams. Now, do you kind of see what I'm saying about the U.S. system versus the other one? Like, if you take like 1 foot, 1 foot is 12 inches, right? Well, I should go the other way. Say 1 foot, 12 inches, what, 3 feet, yard, right? 1/3 of a yard. And so it's hard. Well, the thing is, even if you could create steps, to get from one step to the next is not just moving the decimal over. That's what makes the U.S. system so crappy, right? This is easier to use. Why is the base 10? We call it base 10 because multiplying by 10 moves decimals over. Why is base 10? Why do you think we use base 10? Like, where do you think base 10 came from? Like, why don't we have a base 8, like only 8 digits? You know what I'm talking about? Like, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the only digits we have, right? All of our numbers are made out of those digits. How many are there? 10. Anyone here familiar with computers? They don't use all the numbers. It's zeros or ones. It's called binary. It's base 2, meaning in this number system, there are only 2 numbers, 0 and 1. That's it. That's a base 2 number system. This is base 10. Why do you think base 10, we use base 10 and not base 2, or why not use base 8, or why do you think we use base 10? It is easy to convert because that's what we've learned, but I mean, base 8 would be easy too if that's what we were raised on and believed, you know, we're taught from the beginning. I'll give you a hint. 10 fingers, right? Every 10, right? When counting, this is where it all came from. So base 10 kind of came from the fact that we have 10 fingers. If we had 12 fingers, we'd probably be using base 12. All right, that's it for that. This next one is what we call a conversion table. And this would be something that would be given to you on the test. And what this allows you to do is convert from the metric system to the other system. What's the other system called? You don't know? Metric and then feet and inches and all that? Standard, U.S. standard? I mean, it's weird because the feet and inches all came from Europe. The king used to actually go out there and like, that's a foot. Whatever the king's foot was, that was a foot. You know, like that's where it all originated from. But then even the Europeans got rid of it. Said, you know what, that system sucks. We're going to go to metric, and we still keep it. It's kind of garbage. But if you wanted to go from feet to meters, then you could do it. All right, this is the chart that we use. So let's look at this. What is 1 inch in meters? So you go to 1 inch. Where's meters? Right here. So it's just 0.0254 meters. It's just looking at the table. That's all it is. Read the table. 0.0254. 1 mile is how many feet? So let's look for miles here. 1 mile is 5,280 feet. Did anyone here know that ahead of time? No? No? 1 foot is how many yards? So 1 foot is 1/3 of a yard. 1/3. Okay, so let me ask you this. 2 2.5 miles is equal to how many centimeters? Okay, so you look at this chart, you're looking at miles, right? 1 mile is how many centimeters? Well, we don't have centimeters here, right? So we first have to convert miles to what? Meters. And then once we get it to meters, we convert meters to centimeters off of our little step. But we're not converting 1 mile, we're converting what? 2.5. So first thing I would do is take 2.5 miles and I would multiply it times what? 1609.344. Did I do that right? 1 mile is this many meters. What is that? Meters. And then you take that to centimeters. So you go from meters to decimeters to centimeters. So 2 to the right. Y'all follow that? Questions? 402336 centimeters. All right, there's more stuff here that we're not going to get heavily into in examples, but you should know they're here. A fluid ounce is 1/8 of a cup, is 1/16 of a pint, is 1/32 of a quart, is 1/128 of a gallon. Again, this is your good old U.S. system. You know, there's no easy way to convert. 32 ounces, right? Quart is 4 cups, 2 pints, 1/4 of a gallon. All right, so just know these exist. All right, last thing here, scientific notation. Have you ever typed something into your calculator and got something like this? Comes out with this little E after the number. You're like, what the hell is that? Yeah, some people think that means you have an error. It actually represents another way of writing a number. And this just tells you how many positions to move this decimal place. So if you are given a number 7.345 E negative 5, what it means is you're going to take this decimal and you're going to move it 5 places to the left. If it's negative, you go to the left. If it's positive, you go to the right. So let me rewrite this by moving this decimal 5 places. 1, 2, 3, 4, 5. That's going to produce 1, 2, 3, 4 zeros in front of this. And that's going to be my decimal notation. 0.0007345. Does everyone agree that taking that decimal 5 places to the left gives you that? Is that all right? So this number right here is equivalent to this. Very small number, very big number. Very small. Very small. Okay, and then now in scientific notation, what we do is we rewrite exactly what we have, 7.345, but instead of writing E negative 5, we put times 10 to the negative 5. All that 10 to the negative 5 means, everyone, is 1 over 10 to the 5th. That's what that means. Do you ever remember seeing that negative powers means you can drop it down as positive? You may or may not have seen that in the past. What is 10 to the 5th power? 10 times 10 times 10 times 10, 5 times. It's 1 with 5 zeros. The reason why I'm saying that is because I want you to get on your calculator and do 7.345 and I want you to multiply it times this. In other words, divide it by 100,000. So take 7.345 and divide it by 100,000 and tell me what you get. You get this, right? So all this is three different ways of writing the same exact number. This is called engineering notation, this is scientific notation, this is decimal notation. So when we see negative numbers up here like this usually means this is a very small number. If we see positive numbers up here, it's going to mean it's a big number, as this next one illustrates. 6.18 E3 means I'm going to move the decimal point how many places? To the right 3, which is going to make it a 618. How many zeros after the 8? Just one? So 6.18 E3 is the same as 6,180. How do I write it in scientific notation? 6.18 times, that's times, be careful, that's times, not x, times 10 to the third power, 10 cubed. What's 10 cubed? 10 times 10 times 10 is 1,000. What's 1,000 times 6.18? 6,180. I'll just walk you through this. What would you do with the decimal point here if you want to write this as a decimal? Which way am I going? Left 5 places? If I rewrote it with scientific notation, it would be this number times 10 to the negative 5. Decimal notation, move it which way? Right 5. Scientific notation, this number times 10 to the positive 5. Okay, I'm about to wrap it up, but I wanted to show you one thing. This has to do with numbers. You know what? Can someone kill the lights? Do we all know what a meter is? About how long a meter is? Almost 3 feet. Okay. So if you look at this is I believe that's our galaxy in here, right here. This is the outer space. Okay. 10 million light years. 10 million light years across. Do y'all know what a light year is? Okay. Everyone know how fast light travels? Very good. You know, you're driving down the road 50 miles per hour. Okay. Light travels 386,000 miles per second. That's the speed of light. Every second it goes 386,000 miles. A light year is the distance light would travel not in 1 second, but in 1 year. If you take the distance light would travel in 1 year, that's a long way. If you take 10 million of those light years, you will be 10 to the 23 meters long. So that's 10 to the 23. That's 10 E, no, I should say it this way. 1 10 to the 23. That's basically this one, and move your decimal point over 23 places to the right. "23 places to the right." That many meters, all right, is the distance from here to here. Now what I'm going to do is I'm going to go in, zoom into that box. 10 to the 22 meters, so that's not quite as big, right? You can see is the distance, and there is our Milky Way galaxy, which is a spiral galaxy. 10 to the 21 meters, now we're kind of looking within one of the bands of one of the spirals of the Milky Way galaxy. So 10 to the 21 is the distance across. Now we zoom in again. We're still within the bands. You can see all these different suns out there. 10 to the 19, still getting within the band. Can't quite make a whole lot out. 10 to the 18, you can now just start to see our sun. 10 to the 17. Oh, maybe I was wrong. Was that not it? There's supposed to be some information on this also. No, there it is. Okay, sorry. There's our sun. We're still going in. 10 to the 16. 10 to the 15. Now we're starting to really make out the sun a little bit. Now we can kind of see the solar system in there. Within there, now there's our sun. There's different planets, right? 10 to the 13. I'm just trying to give you an idea of how big a number like 10 to the 23 is. It's a huge number. 10 to the 12. 10 to the 11. You're starting to get into the blue one is the orbit of the Earth. 10 to the 10, you can start to see the moon around the Earth. 10 to the 9, you can see the Earth. 10 to the 8, now you can start to see what's going on. Okay, 10 to the 7 is about the diameter of the Earth. 10 to the 7th power. 10 to the 6, there's Florida. Right? Is that Florida or what? Where is that? Back it up. Are we still in Florida? Okay, Florida. 10 to the 5, starting to make out some city there. 10 to the 4. 10 to the 3. That's 1,000 meters. Less than a mile. Well, yeah. 10 to the 2, that's 100 meters. It's like a football field. 10 to the 1, 10 meters, right? Distance from here to the other side of the room, about 30 feet. 10 to the 0. What's 10 to the 0? What's any number to the 0? 1. That's 1 meter. Now hold on. What does 10 to the negative 1 represent? 10 to the negative 1. What's 10 to the negative 1? That's 1 over 10, isn't it? We said that when you have a negative exponent, it makes it smaller. Okay, so if I go 10 to the negative 1 now, okay, that's 1/10 of a meter. Now I'm looking at the leaf on a plant. 10 to the negative 2, 10 to the negative 3, 10 to the negative 4, right? 10 to the negative 5, starting to see some structure in here. I'm not sure where they got these from. We can see, what's that? What, these guys right here? Yeah, so these are like the cells on the leaf, right? That's what 10 to the 5 meters looks like, 10 to the negative 5. 10 to the negative 6, you can actually see that it says it up here, nucleus of a leaf cell. 10 to the negative 7, chromatin. 10 to the negative 8, now you're starting to get into the DNA strands. 10 to the negative 9, 10 to the negative 10, you're in the outer electron cloud of the carbon atom. 10 to the negative 11, 10 to the negative 12, empty space between the shells. 10 to the negative 13, the nucleus of the carbon atom. 10 to the negative 15, 10 to the negative 16. We don't know after that. But I always thought that this was pretty fascinating. If you look at this picture right around in here, right, it looks a whole hell of a lot like the picture out here. You know what I'm saying? Like, way big, we don't know a whole lot, really. And when you go super, super small, it's almost like the same universe we don't know about. It's kind of crazy. Anyway, that just gives you an idea of like 10 to powers. I've always thought that was cool. I guess we didn't have time for a quiz, so we'll have to do a quiz next time. Have to, because we have to have one per week. Do your homework. Only up to what we've done. Have a nice day.